Learn it fast, learn it smart, learn with us at SOFO. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
Welcome to concept videos from SOFO Learning. Today we want to look at quadratic equations solution models. Specifically, we will look at two solution models, namely factorization method and algebraic method. A quick note, solutions are also known as root of the equation. And before we get into the details of the solutions of a quadratic equation, let's just recap what is a standard form. Standard form of a quadratic equation is ax squared. So we have a square term of the variable with a coefficient a, and then bx. This is the same variable but with exponent 1 and its corresponding coefficient b, plus c, a constant equal to 0. Now the factorization method involves understanding a p and a q, whereas p plus q is equal to b and p times q is equal to a times c. Now, why do we do this? In order to understand that, all we need to do is to apply this p plus q instead of b here, and instead in this p times q in this place. So let's just try that. So it will become ax squared plus, instead of b we get p plus q times x plus the c is p times q by a. So we will get pq by a equal to 0. Now let's multiply a on both sides of this equation. So we will multiply this term, and this term with a, and we can do it easily in our head. So this is a squared x squared plus p ax plus q ax plus pq equal to 0. Now what we need to understand, why did we create this form? It's very simple. We can reduce this form into ax plus p as one term and ax plus q as another term equal to 0. Now this is what we are looking for. Instead of this form, we want to convert that equation into this form. Now this portion could be equal to 0 or this portion could be equal to 0. So if this portion is equal to 0 and either of them, so this is a multiplication, so either of them could be equal to 0 and both this entire term would be 0. So you can say ax plus p equal to 0 and you get one value of x, and ax plus q equal to 0, or we will get another value of x. So you are going to get two values of x as root or solution of this original equation. Now we're going to work through this using an example. The best way to try to understand this concept is to try the multiplication portion first. So I have here an example equation, 2x plus 7 times x minus 4 equal to 0. Now let's try to expand this. So you get 2x squared right here, then you get 7x plus 7x minus 8x minus 28 equal to 0. Alright, now we can further reduce this. You get 2x squared plus 7x minus 8x is minus x, so it's essentially minus x here minus 28 equal to 0. Alright, now let's imagine the p and the q here. Alright, so what we need to think about is p plus q is equal to minus 1, this value right here, and p times q is equal to minus 28 times 2, minus 28 times 2. This is 56, negative 56. Now let's look at these two variables, right? So if you add them together, 7 and negative 8, so you get 7 minus 8 and you're going to get this negative 1, and 7 times negative 8 you're going to get this negative 56. So this is, we're going to do the reverse of this process from this equation back to this form in order to find the root. Now let's look at this example, 3x squared minus 11x minus 20 equal to 0. Now our goal is to find the p and q, right? So p plus q equal to negative 11, p times q equal to negative 20 times 3 or negative 60. Right? Now let's imagine negative 15 and 11 as p and q. So this is negative 15 and 4. I think I made a mistake earlier. I'm sorry. P is negative 15, q is positive 4. So if you add this, you get negative 11. If you multiply this, you're going to get negative 60. So let's rewrite this equation using these numbers, right? So 3x squared minus 15x plus 4x, and together you're going to get 11x minus 20 equal to 0. Now let's look at this portion specifically, and we know that 3x is common between these two terms. So 3x comes out of the parenthesis and you get x minus 5, plus you can see 4 is essentially common between these two terms. So 4 comes out of the parenthesis and you get x minus 5 equal to 0. And this x minus 5 is common between these two terms, which makes it x minus 5 multiplied by 3x plus 4 is equal to 0. Now it's easy to find the solution of the x from here. So it would be this or this, which makes it x equal to 5, x minus 5 equal to 0 or x equal to 5, x minus 5 equal to 0 or x equal to 5, or 3x plus 4 equal to 0. And so x will be equal to, this 4 goes to the other side and becomes negative 4 divided by 3, and that's the other answer of x. So x would be equal to 5 or negative 4 by 3. Let's now apply the algebraic form of the solution, which I have right here. This is the standard formula that we use for algebraic form. It is minus b plus or minus square root of b squared minus 4ac divided by 2a. This is the famous formula. Now let's see what are the variables here. So a is equal to 3, then b is equal to negative 11, this term right here, and c is equal to negative 20, this term right here. So let's kind of apply it here. It's a negative of negative 11, b is actually minus 11, so minus of that, plus or minus square root of b squared. So negative 11 squared minus 4 times a, that is 3 times negative 20 divided by, all divided by 2a, that is 2 times 3. Now this would work out to negative of a negative would be positive, so it is 11 plus or minus square root of 1 121 plus 240, 121 plus 240 divided by 6. All right. Now let's make some space here. The square root of these two terms would be 19. So 11 plus or minus 19 divided by 6. All right. So 11 plus 19. So there are two possibilities here. So let's work out those possibilities. So 11 plus 19 is 30. 30 by 6. This is 5. This is one root or one answer. The other root is 11 minus 19. That is negative 8 by 6 or negative 4 by 3. So that's kind of the second solution. So you get two solutions, same as the previous model that we have tried. Thank you for watching.